Welcome to Paragon International University.
Hello professors and hello everyone. My name is Kimheng Piseth, and today I'm gonna show you guys about my term projects. For my part is 10.2 infinite series in the chapter 10 infinite sequence and series. First of all, I'm gonna show you guys about the table of contents. For A, what is an infinite series? An infinite series is the sum of an infinite sequence of numbers A1 plus A2 plus A3 plus plus An plus . The goal of this section is to understand the meaning of such an infinite sums and to develop methods to calculate it. Since there's finitely many terms to add in an infinite series, we cannot just keep adding to see what comes out. For the result of summing the first n terms of the sequence and stopping, sum of the first n term is an ordinary finite sum and can be calculated by normal additions. Essence equals a1 plus a2 plus a3 plus an. The positive sum forms a sequence whose n term is Sn is equal to 2 minus 1 over 2 to the power of n minus 1. The B definitions give a sequence of number ans and expressions of forms a1 plus a2 plus a3 plus a plus an plus is an infinite series. The number ans is the n terms of the series. The sequence Sn is defined by A1 equals A1, S2 equals A1 plus A2, Sn is equal A1 plus A2 plus plus An equal the sum of AKs from 1 to n. Is the sequence of the further sums of the series, the numbers Sn being the n partial sums. The sequence of further sums converges to a limit L. We say that the series converges that and its sums is L. In this case, we also write A1 plus A2 plus plus AN plus equal the sum of AN from 1 to infinity is equal L. If the sequence of further sums of the series does not converge, we say that the series diverges. C. Geometric series. Geometric series are series of forms A plus AR plus AR squares plus plus AR power of n minus 1 plus equal the sum of AR power of n minus 1 from 1 to infinity, in which A and R are fixed real numbers and A opposite and 0. The series can also be written as the sum of AR's power of n from 0 to infinity. If R smaller than 1, the geometry series A plus AR plus AR squares plus plus AR's power of n minus 1 plus converts to the A over 1 minus R. That the sum of AR's power of n minus 1 from 1 to infinity equal A over 1 minus R. That is all smaller than 1. If the R bigger or equal 1, the series diverges. For example, the geometry series with A equals 1 over 9 and R equal 1 over 3 is 1 over 9 plus 1 over 27 plus 1 over 81 equal the sum of 1 over 9 times 1 over 3 power of n minus 1 from 1 to infinity equal 1 over 9 over 1 minus 1 over 3 equals 1 over 6. The next example, the series of sums of minus 1 power of n times 5 over 4 power of n from 1 to infinity equal 5 minus 5 over 4 minus 5 over 16 minus 5 over 64 plus is the geometric series with A equal 5 and R equal minus 1 over 4. It converts to A equal 1 minus R equal 5 over 1 plus 1 over 4 equal 4. D. The n terms test for the divergence series. One reason that a series may swell to the converse is that its terms don't become small. For example, the series, the sum of n plus 1 over n from 1 to the infinity equal 2 over 1 plus 3 over 2 plus 4 over 3 plus n plus n plus 1 over n plus . That is diverse because the Abdukasim eventually outgrows every reassigned number. N is greater than 1. So the sum of n term is greater than n. For the theorem 7, if the sum of an from 1 to infinity converges, then an could be 0. The n term test for the divergence series, the sum of an from 1 to infinity diverges if the limit n to infinity of an fails to exist or is different from 0. E. Combining series. Whenever we have two convergent series, we can add them term by term, subtract them term by term, or multiply them by constants to make new convergent series. In theorem A, if the sum of an equal A and the sum of bn equal B are convergent series, then we have, for the first point, sum rule. The sum of an plus bn equal the sum of an plus the sum of bn equal A plus B. And the second point, the difference rule. The sum of an minus bn equal the sum of an minus the sum of bn equal A minus B. And the third point, the constants multiples rule, which is the sum of k times an equal k times the sum of an equal k times A, that is any number k. Our corollary of the theorems 8. We have the following results. We omit the proof. 1. Every non-zero constant multiple of the diverse series diverges. Number 2. If the sum of an converges and the sum of bn diverges, then the sum of an plus bn and the sum of an minus bn both diverge. Questions. Remember that the sum of an plus bn can converge when the sum of an and the sum of bn both diverge. For example, the sum of an equal 1 plus 1 plus 1 plus ... and the sum of bn equal minus 1 plus minus 1 plus minus 1 plus ... diverge, whereas the sum of an plus bn equals 0 plus 0 plus 0 plus ... that converges to 0. Adding or deleting terms. We can add a finite series or terms to a series or delete its finite number of terms without altering the series, convergence or divergence. Although in the case of the divergence, this will usually change the sums. If the sum of an from 1 to infinity converges, then the sum of an from k to infinity converges for any k bigger than 1, and the sum of an from 1 to infinity equal 1 plus a1 plus a2 plus ... plus ak minus 1 plus the sum of an from k to infinity. Conversely, if the sum of an from k to infinity converges for any k bigger than 1, then the sum of an equal 1 to from 1 to infinity converges. Thus, the sum of 1 over 5 power of n from 1 to infinity is equal 1 over 5 plus 1 over 25 plus 1 over 125 plus the sum of 1 over 5 power of n from 4 to infinity, and the sum of 1 over 5 power of n from 4 to infinity equal the sum of 1 over 5 power of n from 1 to infinity minus 1 over 5 minus 1 over 25 minus 1 over 125. G. Redexing. We can redex any series without altering its convergence. To read the starting value of the index H unit, replace the n in the formula for an by n minus a. The sum of a n from 1 to infinity is equal the sum of a n minus 8 from 1 plus 8 to infinity equal a1 plus 2 a2 plus a3 plus dot dot dot. To lower the starting value of the index 8 unit, replace the n's in the value. The formula for an by n minus 8. The sum of an equal from 1 to infinity equal the sum of an plus 8 from 1 minus 8 to infinity equal a1 to a2 plus a3 plus dot dot dot. We saw the reductions in studying a geometric series with the index n equals 0 instead of the index n equals 1, but we can use any other starting index value as well. We usually give preference to indexings that lead to simple expression. Example, we can write a geometric series, the sum of 1 over 2n 2 power of n minus 1 from 1 to infinity is equal 1 plus 1 over 2 plus 1 over 4 plus dot dot dot, as the sum of 1 over 2 power n from 0 to infinity and the power of 1 over 2 power 1 over 2 power of n minus 5 from 5 to infinity, and the last one sum of 1 over 2 power of n plus 4 from minus 4 to infinity. The partial sums remain the same no matter what indexing we choose. Here for the product, the sum of 1 over 2n minus 3 times 2n minus 1 from 3 to infinity by the 1 over 2n minus 3 times 2n minus 1 equal 1 over 2 over 2n minus 3 minus 1 over 2 over 2n minus 1, so that n equals 1 over 2 over 3 minus 1 over 2 over 5 plus 1 over 2 over 5 minus 1 over 2 over 2n plus dot 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 plus 1 over 2 over 2n minus 3 dot minus 1 over 2 over 2n minus 1 equal 1 over 2 over 3 minus 1 over 2 over 2n minus 1, and the limit n to infinity of as n equal limit n to infinity of 1 over 6 minus 1 over 2 over 2n minus 1 equal 1 over 6. Practical exercise number 2. The sum of 9 over 3n minus 1 times 3n plus 2 from 1 to infinity by the 9 over 3n minus 1 times 3n plus 2 equals 3 over 3n minus 1 minus 3 over 3n plus 2, so that as n equals 3 over 2 minus 3 over 5 plus 3 over 5 minus 3 over 8 plus 3 over 8 minus 3 over 11 plus dot 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 plus 3 over 3n minus 1 minus 3 over 3n plus 2 equals 3 over 2 minus 3 over 3n plus 2. Now the limits n to infinity as n equal limits n to infinity of 3 over 2 minus 3 over 3n plus 2 equals 3 over 2. And for the practice exercise number 3, the sum of minus 8 over 4n minus 3 times 4n plus 1 from 3 to infinity by the minus 8 over 4n minus 3 times 4n plus 1 equal minus 2 over 4n minus 3 plus 2 over 4n plus 1. So that n equal minus 2 over 9 plus 2 over 13 plus minus 2 over 13 plus 2 over 17 plus minus 2 over 17 plus 2 over 21 plus dot 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 plus minus 2 over 4n minus 3 plus 2 over 4n plus 1 equal 2 minus over 9 plus 2 over 4n plus 1. So the limit n to infinity of minus 2 over 9 plus 2 over 4n plus 1 equal minus 2 over 9. So now is the end of my presentations, and I'm gonna thank Professor, thank everyone for your attention. Goodbye.